All right, guys, welcome back to this channel. I'm super excited to solve this set of questions with you guys. And before this video, I have dropped the one for gamma. So I'm going to drop the link to that video in the description side. So make sure you click on it so you can watch the one for gamma also. So in this class, we are going to be looking at these three questions. Number one, I want to use gamma, the knowledge of gamma, to solve the integral from 0 to pi over 2 cos to the power of 6 d theta. All right, so there is also a video where I did the proof of the polar form of beta function. So I'm also going to drop that in the description section so that you can also be aware of where we are getting the formula I'm about to use. All right, so now we know that a beta function m of n, though it's is can be n and m, and that's is equal to, in polar form now, 2 integral from pi over 2, okay, then cos of 2m minus 1 theta sine 2n minus 1 theta dt. This is right. So I want to compare it with my question. Okay, so I have something like this as my question: pi over 2 cos to the power of 6 theta d theta. Okay, I'm comparing it with this 2 into pi over 2 cos 2m minus 1 theta sine 2n minus 1 theta d theta. So what do you think we can do here to make it equal on both sides? It implies that, you know, I can also make this to be sine to the power of 0 theta. Do you get? So that I can have sine on both sides without altering the question. Okay. So, and again, I want to also bring these two here to this end. So what would that be? That means I'm literally going to be having something like an half, right? So now let's find the value of m and the value of n so we can know what our answer will be. So if you check this transitively, it means that 2m minus 1 is equals to 6. You get that? So, and if I should do the calculations, it means that 2m is equals to 7, because 6 plus 1 is 7, right? And m will be what? 7 over 2. You see? So if I should compare the ones for signs, it means that 2n minus 1 will be equals to what? 0. Then it implies that 2m is equals to 1. Then this means that, sorry, this is n now, n. This means that n will be equal to 1 over 2. So now that I've gotten my values, then I can substitute into the main question. Remember I said we are going to bring the one to the other side so that we can have a full question. So now that I know my values, it means that this can be written as 1 over 2, the beta of 7 over 2, comma what? 1 over 2. And we can remember that beta function, if I want to write it in terms of gamma of m comma n, is what? The gamma of m times the gamma of n over the gamma of what? M plus n. Okay, so that makes everything so simple. All right, so what I will do now is I want to find this one. So I will just have 1 over 2 times beta of 7 over 2, which means I will have the gamma of 7 over 2, right, times the gamma of 1 over 2 over the gamma of 7 over 2 plus 1 over 2, which implies 1 over 2, right? Gamma of 7 over 2 times gamma of 1 over 2 over, now this one is going to give me 8 over 2, which is 4. So that is literally gamma of 4. Okay, so I want to find the gamma of 7 over 2. So I will just use my the formula for gamma to quickly sort that out. So to do that, 1 over 2 times, so to get the one for gamma, that will be, I've explained it in the gamma video, so do well to watch the one for gamma so you can understand what I'm saying. So I would have 5 over 2 times 3 over 2 times 1 over 2, then times the gamma of 1 over 2, then times this other gamma of 1 over 2, then all over 3 factorial. Is that okay? So 3 factorial is what gamma of 4 is, because gamma of 4 is 4 minus 1 factorial. Is that okay? So now, to finalize this question, so I'll just do my calculations. The gamma of half is the root of pi. Okay, so this is the root of pi times the root of pi. That's pi. Is that okay? So that's very simple. So I have 15 over, so 2 times 2 is 4. 4 times 2 is 8. 8 times 2, that is 16. I have my pi here. Then over um 3 factorial, which is 3 times 2 times 1, which is what? Which is 6. Do you grab that now? So I can now do the rest of the calculation. So I think 3 can go here. 3 here is 5. 3 here is 2. So I would have 5 pi over what? Over 32. And that's exactly what this would be. All right, cos 6 pi 6 theta d theta. I hope that is clear. So let's move to question number 2. So I want to take it step by step. That's why I'm taking it this slow. Question number 2. Now, number 2 is very, very interesting. Number 2 says, still using the boundaries, pi over 2 cos cube theta into 1 minus sine cube theta d theta. So some might want to start thinking too far that, okay, which identity am I going to use? Blah blah blah. It's very simple. Just open the brackets. That's all. So pi over 2, I'll have something like this: cos cube theta minus, from your integral property. So I'll just have cos 3 theta sine what? Sine 3 theta. Very simple, right? So that's it. So now I will just apply my formula there. So now if I want to do this one from question 1, I'll just say just straight up. So 2m minus 1 is what? Is 3. 2n minus 1 is what? 0, as per sine raised to power 0 for this first part of the integral. So I'll just have, let me just divide the by 2 so I can solve it directly. So this will be 4. So 2m equals to 4 as per 3 plus 1. Then m is equals to 2. Here n is equals to 1 over 2. So we are basically, because there's nothing here, so we are basically looking for 1 over 2, the beta of 2, right, comma 1 over 2. That's for the first part. Then for the second part, we would have, this one is very simple for us to achieve. We know that 2m minus 1 is equals to 3. 2n minus 1 is equals to 3. So m is equals to 4 over 2, right? Then n is equals to 4 over 2, which means that m is equals to 2, n is equals to 2. Right. So it means 1 over 2 beta of 2 comma 2. Very simple. So let's just solve that with our function of gamma. Oh yes, of gamma to get our final answer. So 1 over 2 times the gamma of what? Gamma of 2 times gamma of 1 over 2, right? Over, I will add it together. So 2 plus 1 over 2, that is 5 over 2. Okay, minus 1 over 2, gamma of 2, gamma of 2 over the gamma of what? Gamma of 4. Very simple, right? So very simple to deal with. Now, to finish this up, I would have 1 over 2. Gamma of 2 is 1 factorial because 2 minus 1 factorial is gamma of 2. Then the gamma of half is the root of pi over gamma of 5 over 2 is actually 3 over 2 times 1 over 2 times gamma of half, which is still, root of pi that will cancel out this and this. That one is out like that. Minus 1 over 2 times 1 factorial times 1 factorial over what? Over 3 factorial. So I would have 1 over 2 times 4 over 3 because that's the reciprocal, minus 1 over 2, 1 over 6. Do you get that now? So these 2 here, 2 here is 2, that's 2 over 3 minus 1 over 12. So the LCM here is 12. So 3 in 12 is 4. 4 times 2 is 8. 8 minus 1. And that's exactly 7 over 12. That is the answer to question 2. And let's go right into the last question. Again, this is BAM Students Academy. If you know you have not subscribed yet, Abba, click the subscribe button and let's enjoy this YouTube channel together. All right. So let's quickly solve this question 3. So question 3, I have the square root, of course, the integral 0 to pi over 2 of tan theta of what? So when I first saw this question, I was like, which identity will I use? And it's just done on me that it's very simple, right? So I just say 0 to pi over 2. I can write this as this, raised to power half, right? See that? And I can also write it as integral from 0 to pi over 2 into sine theta over what? Over cos theta. Is that not still tan? Exactly. So now this is also equal to the integral from pi over 2. If I should share it to them, I will have something like this: sine 1 over 2 theta over what? Cos 1 over 2 theta. Do you get what I'm trying to do? So if I should bring up the cos as per the general formula, the general polar form, it will look like this. It will look like sine raised to power half theta cos what? Minus 1 over 2 theta what? Then we can use our beta function. See how simple it is. So now, in this kind of scenario, there's a 2n minus 1 is equals to what? 1 over 2. Abi? And our 2n minus 1 is equals to what? Minus 1 over 2. That I will just solve that. So 2m is equals to 3 over 2, right? Which means that my m is equals to what? 3 over 4, right? Same thing here. My 2n is equal to 1 over 2. That means minus half plus 1, that's half. Then my n is equal to 1 over 4. Very interesting, right? That's it. So it means that I'm literally looking for 1 over 2, the beta of 3 over 4, comma 1 over 4. That's all. So this is what I'm going to work with. So let's just clear this part. Very interesting question. Now, here comes the tricky part of this question. If you're not careful, you might want to start beating around the bush. So now, remember, let me just write it with a red pen. So recall that the gamma of p, let's say a number, and 1 minus p is equal to pi over what? Sine p pi. That's it. Where what? Where p is less than 1. Do you grab now? So now that p is less than 1, what do you see here? You can see that this can be expressed exactly like that. Look at what I'm saying. If I have 1 over 2, what is better of this? Is actually better of 3 over 4, Abi, times, gamma of 3 over 4, gamma of 1 over 4, over, if I add it together, the gamma of 3 over 4 plus 1 over 4, right? And what would I have? It's kind of giving me something interesting there. So I would have, you see what I'm saying now, 1 over 2 into what? Into the gamma of 3 over 4, the gamma of 1 over 4. Is that okay? Then 3 plus 1 over 4, that's gamma of 1, and that's still 1. So it doesn't have any effect on it, actually. Okay, so this is out. So if you notice the pattern very, very well, you will see that 1 over 2, I can still rewrite this as the gamma of 1 minus 1 over 4 times the gamma of what? 1 over 4, which is what I'm trying to portray to you. You see that if I can write it in this manner. So what is our p in this case? Our p is what? Our p is 1 over 4. So what will be my answer? Very simple. 1 over 2, then pi what? Pi over what? Sine what? Pi over 4. Very simple. So in a nutshell, this particular question, the answer to it is what? Pi over 2 sine pi over 4. Very interesting question. All right, guys, thank you so much for this for your time, and I still want to remind you to click on the subscribe button. All right, so, and yes, I will see you in the next video. Thank you.